fellow programmers. Welcome back once more to this Drives course. And today we're going to be looking into two topics. Our first topic is our physical ground. Why is it important? And even though this seems like a pretty obvious topic, we need to explain this. Now, what is a physical ground for? Basically, the same thing for what an emergency stop is for. First off is equipment protection. If there is an electrical discharge for any reason, for something that we were unable to control, then the physical ground is going to help us protect our equipment by discharging that excess energy for this terminal. Okay? So, what is our next point? Our next point is our own protection. Now, I've seen and I've been able to review and I've analyzed our electrical connections in our industrial cabinets. I don't know if this has happened to you guys, where we have our line and our application, whether it's for the cabinet itself or out of the machine, where we get our very famous, shocks. If there's some sort of voltage, and if we apply for the machine, and we immediately feel that current. So it seems that if we're not careful, that voltage might be able to damage, or it could even hurt us. If it's pretty high voltage, we're gonna get a pretty good shock. So when this happens, it's because there's no ground connected to our devices. And remember, guys, we connect this everywhere. On our machines, in the cabinet, in our drive. The motor itself has the signaling for ground, so we need to be very careful with this. Okay, this is equipment protection for all equipments, and most importantly, personnel protection for people. This included, obviously, ourselves. So we need to ensure to always connect physical ground. Okay, which is what I was saying. It's not only for our drive, but also for our motor. Now, beware, guys. I know this is going to sound pretty obvious, but the physical ground itself is apart from the neutral. There's also certain cases where people have gotten confused. It's not the neutral. Neutral is neutral. Physical ground is something else. If the customer does not have this, we need to really push for this. Because if the device starts getting damaged, who do you think is going to be to blame? The engineer who is adjusting the drive or setting up the drive or running the connections. And that's where they blame us. Also, that it's a pretty important norm and regulation. We always need to have our physical ground. If the customer doesn't want it, they need to give it to you, hand it to you in writing, but for your own protection. This is a fact. This always needs to be a physical issue. That's the first point. Now, what's next? Mounting considerations. Our drive, when we buy it or when we get it, we need to install it in an electrical cabinet. Okay? So we need to install this in the platen. So I've also seen, based on experience, pretty poor installations for servo drives, for electrical devices, and even the same PLC. So we need to be very careful with this, guys. It's not complicated, but these are rules that we need to follow. Now, what are these rules? For example, always you need to have some sort of separation, whether it's for the gullet or for the cabling, for the wire, okay, because we're generally going to analyze this. They come from the top where they're in the feed. We need to feed our drive. So therefore, this needs to come up from the top. But from here, from this piping, from this gullet, we need to have some sort of separation of 50 millimeters, at least. It's not if we wish to. No, this is the way that it needs to be. As well as for the bottom part, 50 millimeters. What happens if I don't have my my gullet? It doesn't matter. For the end of the drive, all the way to where the other device starts for cables or whatever, there needs to be a separation. Why? Because if not, we might damage our drive. Okay, our drive, remember that internally, it's always going to be running the inverter part for voltage, which we had already previously explained. And we always have an internal voltage. There's always going to be some current. So we need to be capable of eliminating all of this, the most temperature as possible. So the back gutter has a fan. And that fan is going to work on the top part. So then the air is going to enter through our fan. And it's going to come out on the bottom part. Now, generally, we have our fan, which is placed on the back part. And it has some energy spreaders, some thermal, which look like this. So here on the top part, we have our fan, whether it's here or on this other side. Okay, we have our fan, and it should be cooling our air, but also cooling the internal circuits in our drive. And that energy, that temperature, should start getting eliminated. So all of these are heat sinks, which if you guys have are experimented in electrical devices, you know that these exist. So our drives are not the exception. They have it in the back part. Now, what would happen if we don't have the proper ventilation? Our drives are generally damaged. So this is why this is very important. It's not about damaging it. On the contrary, it's about taking care of it. Now, how are they taken care of? With proper cooling. And how does this cooling happen? Thanks to the fan that it's already put in. It's internal. All drives have this. So therefore, we need to respect these dimensions. So, if we need something specific on our lateral part, generally, it has a 2 millimeter limit. Not on the back part. It's not so much a big problem. But on the upper and lower part, vertically speaking, we need to have this space. If we don't have this, we need to be very careful because that drive is going to burn off. And truly, they do burn out. So you need to be very careful with this space. So 50 millimeters at least. And then, for example, here, Alan Bradley recommends us. They say, all right, so if you want to leave them horizontal to the drives, you can install them like this. But do you really have enough space? If not, don't even move it. Okay? What do I recommend? If there is no other way, for you guys to not keep the drives vertically, well then, in that case, what you can do is you can install the drives in the front. I wouldn't recommend this, okay? Honestly. Whenever someone asks me, because I've seen drives, I've seen PLCs that are set up this way, they're horizontal, okay? I don't recommend it, but to each his own. Why don't I recommend this? Because it's not its natural positions. This is the natural position, that they're vertical. And I have had the opportunity to see that the basic useful life, even though the manual says that we can add it in this way, horizontally, I've seen that they do get damaged. And the circuits, since it's not their natural positions, whether it be for gravity or whatever physical reason, it can be affected. Also, it's not comfortable. It's not comfortable to configure our drives in some sort of emergency, because we need to turn our head, and we also need to identify or check the alarm, etc. So that's why I don't recommend this unless there's no other option. If there's no space or something or whatever, if you already ran your probability, and then you may say, you know what, I can't connect this vertically. All right, then in this case, we have to connect it vertically. Horizontally, sorry. But I don't recommend this. The space between the devices need to be at least 2 millimeters. But also try to have a little bit more extra space, so that in case something were to heat up or overheat, they don't necessarily touch between each other. So that's why we need some space at least. The suggested amount is 25 millimeters between drives, or 50 millimeters between drives. So this is the mounting recommendations. All we need to do is to learn this. 5 centimeters or 50 millimeters upwards and downwards. Okay? So with this, we're basically done with our topics, both topics, which were our physical ground and our mounting considerations. We also saw our electrical installation parts and their protections. So having said this, we should be able to install our drive. Okay, this is pretty simple, guys. All right. Now, with this, we're going to move on to our next topic. Thank you very much for your attention, guys.